Okay, what we have seen in the previous turns, the reliable data transport, and we have seen the finite state machine model for that. But as you might be observing, that the problem with that particular version of protocol is that when you send one packet, you get the positive acknowledgement of that packet, and then only you can send the next packet. And in this way, if you do the things, it would be, uh, you know, the bandwidth utilization would not be adequate. So, what is the next proposal? What is the next thing is that you can allow sender may allow multiple in-flight and yet to be acknowledged packet. So keep on sending data packet to data packets are without waiting for individual acknowledgement. Data packets are getting sent from source to destination, and acknowledgement packets are coming from destination to source. And then you somehow make this synchrony of data packets with acknowledgement packets. So obviously, if you want to have a pipeline kind of thing, then you need to increase the range of sequence number, and there has to be buffering at sender and or receiver. So there are two generic forms of pipeline protocol. One is go back and another is selective repeat. These are generic, these are not implemented, but based on this, little bit of go back and little bit of selective repeat, the TCP protocol has been created. The TCP, how TCP handles the many packets in flight, that is created. Fine. Now, if we see and compare these two protocols, these two generic protocols, go back and selective repeat. In go back and sender can have up to n unacknowledged packets in pipeline, and receiver only sends a cumulative acknowledgement. And receiver is not going to acknowledge the packet if there is any gap. Sender has a timer for the oldest unacknowledged packet. If timer expires, retransmit all the unacknowledged packets. So that's why it is known as go back n, that you need to go back and again retransmit all the packets. So here important point is that receiver only sends the cumulative acknowledgement, and if there is any the packet sequence number, the acknowledgement will not be sent. Sender will maintain the timer for the oldest unacknowledged packet, and if the timer expires, all the packets would be retransmitted. On the other hand, if you see selective repeat, sender can have up to unacknowledged packets in pipeline as before. Receiver sends individual acknowledgement for each packet. So it's not cumulative, it's individual acknowledgement for each packet. Sender maintains timer for each unacknowledged packet. And when timer expires, retransmit only the unacknowledged packet. So that's why it is selective repeat. You can retransmit the packets by doing some selection, that the packets who are not getting the acknowledgement in time, then you can only retransmit those packets. Both pipeline protocols have their pros and cons. As you can see that here you have to send many acknowledgement. Every packet need to be acknowledged in selective repeat. In that sense, in go back and you are only sending the cumulative acknowledgement. Now let's see each protocol in detail. Now these both protocol are known as sliding window protocols, and please be very careful while I explain this sliding window, both in case of go back and selective repeat, because this is most important, and because on the basis of this only the TCP sliding window uh, has to be understood. So you can see uh, this is a version of a sliding window. Fine. So there is a k bit sequence number in the packet header. Every packet is going to have a sequence number. Window of up to n consecutive unacknowledged packets is allowed. Fine. So right now we are saying that window size is n. Fine. And how actually this window size is calculated, what is the complete size or the total size of window, that we are not discussing right now. We are just assuming that window size is n. Now in this window, you can see that there is a right edge and then there is a left edge. So the packets which are having sequence number less than the left edge, which are in green color, are known as sent and acknowledged, already acknowledged. Packet beyond the right edge of the window cannot be sent because they are not inside window. Within the window, there can be situation where some packets have been sent, not yet acknowledged, and some packets may be sent more because they are inside the window. So if you see, there are few pointers need to be maintained. One is the send base. What is the left edge? Where is the left edge of the window? And when you add send base plus window size, you'll get the right edge. And within the window, there is a pointer next sequence number which can be sent without waiting for acknowledgement. These packets can be sent without waiting for the acknowledgement. When you see ACKN, when you get ACKN, this will acknowledge all packets up to including the sequence number n. So suppose I have sent 1, 2, 3, 4, 5. I have sent these packets. And if I get the ACK number 5, it means all the packets, including fifth packet, is acknowledged. Sender may receive duplicate acknowledgement. We'll be seeing this when we see the receiver. Now timer is maintained for the, so there is a little bit confusing thing. We'll be coming to this. Timer is maintained for the oldest unacknowledged packet. So here, what is the oldest unacknowledged packet? Whatever is at the send base or the left edge of the window. So this is the oldest unacknowledged packet because after this packet, many packets have been sent. So timer is maintained for this particular packet. Now, when there is a timeout, what you are going to do, you are going to retransmit the packet n and all higher sequence number packets which have been sent and are in the window. So things are very simple. You keep on sending the packet. Fine. If sender receives acknowledgement to the number of acknowledgement and below that number, every packet will be considered acknowledged. The timer would be maintained for the oldest unacknowledged packet. And if there is a timeout on nth packet, so packet n and all other higher sequence number which have been sent already would be sent again, retransmitted. This is the go back n protocol. Fine. Now let's move ahead and see the receiver. So if you want to see the FSM of sender, this is what is the FSM for the sender. Let me take the snip. So you can see here, so we are maintaining the old previous function calls. So if you want to send any data, RDT underscore send data. So what you need to do now is do some checks. If the next sequence number is less than base plus n, means the base plus size of the window. If the next sequence number is within this limit, that's what you need to check. So means the next sequence number should be within the window. If this is the situation, then okay, then you can send the packet with next sequence number, make the packet, send the data and checksum. And then you use UDT send. If base is equal to next sequence number, suppose your send base and you are sending this very packet, means this is the oldest unacknowledged packet. If base is equal to next sequence number, then you have to start the timer and increment the variable next sequence number. So there is at the sender, there are certain variables. One is the window size n. Then there is a variable next sequence number. So when you get the data from above, you want to use RDT send data. This is the event. And what actions are going to perform if the next sequence number variable is having the value within the window, then you create a packet. If in any case that next sequence number is equal to the base, then start the timer, increment the next sequence number variable value. If this is not the case, so there are two ifs you can see. So if window के अंदर है और फिर उसके अंदर अगर बेस और सीक्वेंस नंबर बराबर है तो टाइमर स्टार्ट करेंगे. We'll increment in any case, we'll increment the next sequence number. Else, refuse the data. So this is the first thing. Now this is the initialization. You'll make base equal to 1 and next sequence number equal to 1. This is the initialization thing. Now when you receive a packet and it is not corrupt, what you're going to do, suppose I have a window from 4, I've sent 4, I've sent 5, I've sent 6, I've sent 7, I've sent 8. Right now at the base is the 4th. Timer is running for the 4th. So suppose you receive ACK 5. What will happen? And that is not corrupt. What will happen? Base will be shifted. Obviously, when you receive sequence number 5 means 5th packet which have been sent, 4th packet which have been sent, both are going to be out of the window, means you have to shift the base. Because now, what is the case? When you get the acknowledgement, what is the case? These packet will become green. Suppose you move from here to you get the acknowledgement for this number, so your base will start from here. All these packet will become green. That's what I was trying to explain. So base will be shifted to where? ACK 5 plus 1 means base will be here, and 5 and 4 will go out of the window from the left, means these are sent and acknowledged. So base will be shifted as 6. Now in any case, if base, suppose after doing this, the next sequence number value, variable value and your base are equal, then you have to stop the timer. Or if that is not the case, then start the timer. You'll get to know why we are stopping it, because this will be covered here when you want to send the next data. If base is equal to next sequence number, you are going to start here Fine. Otherwise, you start the timer again. Start the timer again. So we'll take these cases, don't worry. Now on timeout, what is going to happen? If there is a timeout, you start the timer and you suppose there is a timeout for packet number 7. So when you have already sent packet number 7, you've sent your next sequence number is, because you have sent packet number 7, next sequence number would be 8. And now there is a timeout for 4. What you are going to do? From base, from 4, you'll send 4, 5, 6, and 7 again. And that's what is there. Next sequence number -1. 8 minus 1 up to 7 you'll retransmit after starting the timer for 4 again. Now if you receive a packet and it is corrupt packet, do nothing, because that will be taken care here on the timeout thing. Corrupt packet, you are not going to do anything. And in this case, when you retransmit, that may be duplicate packets over there. That may be duplicate packets at the receiver. Any problems in this? I can explain it again if you want. Any problems to anybody? Yes, Abhigyan?
No, sir.
Okay, if there is no problem, then Abhigyan will tell other things. So I'm just making a window, fine, and I'm just trying to make some case, and Abhigyan you will answer, and whatever you will tell, I'll do on the board. Suppose this is the situation right now, fine. So our packet number 6 is here, 7 is here, 8 is here, 9, 10, and 11. Suppose this is the case. Beyond 6, everything is sent and acknowledged. Beyond 11, nothing has been sent. My next sequence number variable value is 10. Fine, means this pointer is here. Now begin. What are the packets which have been sent and acknowledged?
So from 1 to 5,
From 1 to 5 have been sent and acknowledged.
they've been sent and acknowledged.
What is the send base right now?
6.
6. Send base, okay. So what are the packets which have been sent but not acknowledged?
6 to 11.
6 to 9.
10.
Because
6 to 9, sorry.
6 to 9, because your next sequence number is 10.
Sequence number is 10.
10. So 6 to 9 have been sent but not acknowledged. Now if I suppose I receive ACK 7, what will happen?
Yes, sir. If
we receive ACK 7, what will happen?
Sir, the base pointer will move to 7.
Move to 8.
Move to 8.
8. And now your window would be from 8, 9, 10, and 11. And your next sequence number will remain at 10. Fine. In this case, your window has been shifted from, because 7 you have received, these two jabs are out of window, and your window will start from 8. Your send base has shifted. Okay. Now suppose if you receive in this position, if you receive ACK9, what will happen? Your window will start from 10. It would be having 10 and 11. Yes or no?
Yes, sir.
Now now the send base and next sequence number are equal. What does it mean?
Yes, sir. Can you repeat?
Now the send base and next sequence number value are equal. What does it mean?
Sir, the start timer.
You have to stop the timer. Okay? See here.
Yes, sir.
You have to stop the timer. Okay?
Yes,
And
sir.
that will be started again here. You can see if base equal to next sequence number. Okay? That will be started again when you want to send some more data. Got the point? Now suppose you
Yes,
are
sir.
timeout and timer is maintained only for, suppose you time out. Suppose I draw a situation where 7, 8, 9, 10, 11, 12 are in window. The next sequence number value is say 10. So next sequence number is here. And suppose you time out. So timer is maintained here for what packet? The oldest unacknowledged. So these are the packets which are sent but not acknowledged. What is the oldest unacknowledged? This one. Okay. Now if you time out, what will happen?
So it will start from 10 next timer.
It will start from 10. You will timing out on 7, no? 7 सबसे पहले भेजा
अच्छा,
गया.
so it will
Start
it
from
will start in that when
case
we send data, it will start from
7, and now this is the case. If you see it carefully in the this is the, if you time out, you start the timer, you send packet from the base plus 1, and कब तक भेजना है? Next sequence number -1. So what is the next sequence number? Next sequence number is 10 minus 1 means from 7 to 9 you have to send it again. Now got the point everybody? Up again?
yes, sir.
So you might be wondering why we are resending it, because हो सकता है पैकेट वहां पहुंच गया हो, आप दोबारा भेज रहे हैं, वो सब चीजें ठीक है. But first of all, the first goal of designing any protocol that it should be sound and it should be having no errors. Fine. The protocol should be working fine in any of the situation. Fine. Now just see the sender part now. We have seen the sender part. Now what will be happening at the receiver? You receive the packet. Let me take the snip of this also. What is happening at the receiver? Just see. You receive a packet which is not corrupt and has sequence number which is the expected sequence number. Means first of all what? Receiver has to maintain a watchdog, a timer, a watchdog, so that receiver can know कि यार 7 आ गया, 8 आ गया, 9 आ गया. What is the next expected sequence number? It is 10. So if you receive a packet which is not corrupt and has a sequence number which is expected sequence number which you are expecting, then only things are fine. Then only things are fine. Otherwise, you'll just drop the packet. If packet is out of order, drop the packet. Don't buffer it. So if everything is fine, then extract the data, deliver the data, and make a acknowledgement fine with the sequence number. Whatever you are expecting has been received. Means 10 expect कर रहे थे, 10 आ गया तो AC के 10 अपन डालेंगे expected sequence number, and we'll increment our this variable expected sequence number. So what receiver is maintaining? Receiver is not maintaining any window. Receiver is just maintaining a variable expected sequence number, and that expected sequence number is able to tell you that uh, whether there is any gap in the sequence number or not. If there is any gap, suppose you are expecting 10 and you receive 12, you just drop the packet number 12, because this is not expected. ACK only, what? Always send acknowledge for correctly received packet with highest in order sequence number. May generate duplicate acknowledgement, need only remember the expected sequence number. Out of order packet, discard that, and re-acknowledged packet with highest in order sequence number. And this is why you are going to get the duplicate acknowledgement. Suppose you are waiting for 10 and you receive 13. So you'll discard this packet, but you send the acknowledgement with highest in order sequence में 10 तक सही आया है या 9 तक सही आया है, you will re-acknowledge packet with highest in order sequence number, but you are not going to buffer the packet. So what is the role of receiver? The role of receiver is very simple. Just maintain a variable expected sequence number. Keep on checking with the sequence number of received packets. Keep on comparing it the expected sequence number. If it is okay, then fine. Deliver the packet, generate acknowledgement, fine, and increase the value of increment this variable expected sequence number. Otherwise, discard the packet and send the acknowledgement with highest in order sequence number. And that's how it may generate duplicate acknowledgements also. So this is what is and initialization is this expected sequence number 1, send packet, acknowledgement, and checksum. So this is what is sender and receiver FSMs in GBN. Now let's see GBN in action. Please be with me and try to understand this. What is happening? Any confusions in this?
So,
Yeah.
so why are we acknowledging the packet which we are going to discard?
You tell me.
So I get that we are like you explained before. So if we have received till packet number 10
Mm-hmm.
and then we receive packet 13, so then we'll be responding with ACK 10 for
Mm-hmm.
the next received packets. But
Like
why
here
are we
also
doing
you
that
are
for
doing.
every packet?
Here also you are doing. You receive packet 3 and discard, but you have sent acknowledgement number 1 again. That's what you are asking.
Yes, sir.
Why we are sending it? You tell me.
Hmm.
Think about it. म्यूट कर लो थोड़ी देर के लिए. Anybody can answer this?
The expected sequence number is
So we are trying to tell that this is the expected sequence number.
yes, sir. So that's why it is
You
sending
are trying to hammer this. ठीक है? कि this is what is the expected sequence number. Means this duplicate. So let me draw the scenario. Let me draw the scenario, and then it will be clear. Fine. Suppose I say there is a sender and this is a receiver. So let us start from 1. So I have sent packet number 1. I've sent packet number 2. Packet number 3. So these are expected. Fine. And suppose I send a cumulative acknowledgement ACK 3. ACK 3. What it will do? It will acknowledge all these 3 packets. Now I can send packet number 4. Packet number 4. Packet number 5 is last. Packet number 6, 7, 8, all these are received. Packet number 5 is last. And right now the timer is running for 4. Timer is running for 4. Okay. Now when packet number 4 has been received, after some time packet number 4 might have been acknowledged. ACK 4. Fine. And ACK 4 might have reached. So 4 is out of the window because 4th acknowledgement be received. Okay. Now what you are going to do, you are going to discard 6, 7, and 8. You're going to discard 6, 7, and 8. Fine. You have sent 5, you have sent 6, you have sent 7, 8. 5 was lost, and that's why 6, 7, 8 are also discarded. But when you receive 6, you will send what? ACK?
4.
4.
4.
Then again you will send ACK.
4 only.
4.
Again you will send ACK 4. Now, where this will fit in, these acknowledgement, where these will fit in our state transition diagram, let us see. Think over it, where this will fit in. We'll receive a packet. Think by yourself. These duplicate acknowledgements, where they will fit in this whole scenario.
So they will restart timer.
Hmm?
Restart timer.
So suppose this is the case. See the mouse pointer, yes or no?
Yes, sir.
Okay. So what you will get a duplicate acknowledgement here. Okay. You'll get a duplicate acknowledgement here. Where is the scene? Where is our scene? Our scene is here. 4 is already out. Okay. 4 is already out. We receive the acknowledgement number 4. Fine. We receive the acknowledgement number 4. Every time we'll receive the acknowledgement number 4, which is out of the window. Fine. Now see where it will fit in. Which is not corrupt. Base will be what? Get acknowledgement number plus 1. Base set हो गया. And timer will be what? Started. Timer will be started. What does it mean? What does it mean? Timer को फिर से start कर दिया. क्योंकि next sequence number तो आगे चला गया होगा ना? Next sequence number have moved ahead. See here. Next sequence number is because you have sent 5, 6, 7, 8. So next sequence number is 9. Yes or no, Abhigyan? In this case. And you are sending acknowledgement for out of the order received packet every time acknowledgement will be received and received correctly, suppose. Fine. Every time acknowledgement number is received and received correctly, what is going to happen that you get the received packet number plus 1 बेस सेट हो जाएगा. बेस नेक्स्ट सीक्वेंस नंबर के बराबर नहीं होगा. तो हम क्या करेंगे? इस पैकेट के लिए फिर से टाइमर शुरू कर देंगे. इस पैकेट के लिए फिर से टाइमर शुरू कर देंगे. व्हाट इज द आइडिया बिहाइंड दिस? ये क्यों किया जा रहा है? प्रोटोकॉल डिजाइनर की सोच क्या है इसके पीछे? कि डुप्लीकेट को डिस्कार्ड तो कर दिया, ठीक है, डुप्लीकेट पैकेट को उधर डिस्कार्ड तो कर दिया, बट इधर टाइमर फिर से शुरू कर दिया. सपोज इसका टाइमर ऑलरेडी 15 पहुंच गया था, इसको फिर से 0 कर दिया डुप्लीकेट जब एक्नॉलेजमेंट मिला. ये क्यों किया गया? जो भी आंसर इसका देगा उसको कुछ क्रेडिट मिलेगा. ये सब विज्ञान. करीमुल्ला, is anybody who can answer this? तन्मय,
Not sure, sir.
दिमाग लगाओ. चल फिर से एक बार रूल देखते हैं. रिसीवर के लिए, ठीक. Always send acknowledgement for correctly received packet with highest in order sequence number. Highest in order sequence number. Out of order आया लेकिन अगर correctly received है, ठीक है.
सर इसके लिए क्या कि सर मान लो 5 पैकेट जो अपन का एग्जांपल ले रहे थे, 5th पैकेट गया नहीं था, तो अपन एक्नॉलेजमेंट 4th का देके वापस टाइमर स्टार्ट कर रहे हैं, तो 5th वाला अपन को वापस रीसेंड करने का वो मौका मिल जाएगा।
देखिए एक बार, 5th तो वैसे भी रीसेंड करते हैं, हम नहीं भेजते तो टाइम आउट हो जाता 5th पे। एक्नॉलेजमेंट नहीं भेजते अगर अपन, तो क्या होता, टाइम आउट हो जाता थोड़ी देर में। सपोज हम यहाँ पे एक्नॉलेजमेंट नहीं भेजते, इसका भी नहीं भेजते, इसका भी नहीं भेजते, इसका भी नहीं भेजते, क्या चेंज आता विंडो में? कोई चेंज नहीं आता, क्योंकि एसी के 4 तो आप भेज ही चुके हो, नो? इसका रिस्टार्ट करने से टाइमर क्या फर्क पड़ रहा है हमको? और अभी टाइम आउट नहीं हुआ है। टाइम आउट सपोज होने वाला था यहाँ पे, सपोज 20 पे टाइम आउट था, 15 पे पहुंच गया, तो एक डुप्लीकेट एक्नॉलेजमेंट आ गया, मीन्स जो ऑलरेडी इन ऑर्डर पैकेट था उसका एक्नॉलेजमेंट फिर से आया। अगर आया उसके पास, सेंडर के पास वापस, तो वो क्या कर रहा है, पैकेट को देख रहा है और टाइमर स्टार्ट कर दे रहा है।
सर 5 का पैकेट मतलब बाद में गया, तो उसका टाइमर बाद में चालू हुआ है। सो 4 का रिस्टार्ट करके हम ये करें, इंश्योर करें कि
तो
4
4
दोबारा।
का कहाँ स्टार्ट हो रहा है? सी हियर, व्हेन वी रिसीव ए पैकेट, ठीक है, रिसीव पैकेट 4 आया, नंबर +1 किया तो बेस हो गया 5, यस, एंड टाइमर विल बी स्टार्टेड फॉर विच पैकेट? Very fine answer is there. I just want you to think by yourself. So let's revisit the sender, considering this case also. Maybe you can get some hint. Okay. Let me take the snip again and explain you the sender FSM. Fine. Get the data, next sequence number. So whatever is the base plus n उससे छोटा है. Send the packet. Fine. Suppose you are at 5. Fine. So 6, 7, 8. Suppose I want to send packet number 6. So 6 is between base and base plus n. That's okay. We have sent packet number 6. Next sequence number will become 7 is the next sequence number value. Timer is already running for 5 because you are sending 6. So when you send a packet, next sequence number will become 7. Base is at 5. So timer will not be started. You just increment the, so you just increment the next sequence number, which you have already done. So suppose this is the case. We have 5, 6, 7, and 8. You have sent 5 already, 6 already. So next sequence number is already at 7. You have already sent 6, and next time you want to send suppose 7. So next sequence number is already at 7 because when you send 6, sequence number will be incremented. So use 7 as a sequence number. Fine. Send timer will not be started because 5 is the oldest one. Increment the sequence number to 8. So this is how the things are going on. So every time you get the thing, timer is still running for 5 and you keep on sending the packet. And when you have sent 5, 6, 7, 8, suppose you have sent 5 and you have sent 6, you have sent 7 and you have sent 8. Fine. Suppose 5 is lost and 6 is received correctly. What will happen? You will send ACK. What?
4.
4.
Or
Suppose 5 is lost, but 6 is received. It is not expected sequence number. Fine. Expected sequence number is 5. You send the acknowledgement number 4. Timer is running for 5. You send the acknowledgement number 4. Now this acknowledgement number will be here. Okay. So you receive the packet. Obviously, acknowledgement number is not corrupt. And here you have discarded 6. 6 is discarded. Now what you do? Base equal to. So you get the acknowledgement number. Acknowledgement number is 4. You did 1, 5. Fine. Fine. Base will be 5 now. No problems. Okay. Base is not equal to next sequence number because next sequence number is 8. Fine. So will you start the timer? And what it will give you?
Sir, 5 may come after 6, so we are waiting for 5.
5 may come after
6.
5 may come after 6. Come again. 5 may come after 6. So you are saying 5 is not lost. Okay.
Yes, sir.
You're saying 5 is not lost. It is not dropped. It is delayed. That's what you are saying.
Yes, sir.
And there is a reason behind, क्योंकि तुमको ऐसा इसलिए लग रहा है कि यार पैकेट वहां पहुंच रहे हैं और एक्नॉलेजमेंट आ रहे हैं, इसका मतलब हो सकता है वो ड्रॉप ना हुआ हो, डिले हो गया हो. That's what you are trying to say.
Yes, sir. Or maybe in network. It
नेटवर्क
may.
में कहीं फंस गया हो, कहीं दूसरे रास्ते से आ रहा हो. That's what you are trying to say.
Yes, sir.
उससे फायदा क्या होगा?
सर 5 के लिए और टाइम मिल जाएगा आने के लिए, टाइम आउट नहीं होगा.
5 टाइम आउट नहीं होगा, लेकिन 6, 7, 8 तो दोबारा नहीं भेजेंगे अपन.
यस सर, मतलब बेस बढ़ जाएगा ना, एक पैकेट सेफ होगा बस.
क्योंकि एक्नॉलेजमेंट आ रहे हैं इसलिए हमको ऐसा लग रहा है कि थोड़ा चांस 5 को और दे देना. That's what you are saying.
यस सर.
मे बी 5 को थोड़ा और वक्त मिल जाएगा. और बट अगर वो सही में लॉस्ट हो गया होगा तो तब तो हर बार तुम टाइमर बढ़ा दे रहे हो उसका। और काफी देर बाद जाके पता चलेगा। ठीक है, ऑब्वियसली इधर विंडो रुक जाएगी, 8 के बाद तुम भेज नहीं पाओगे। ठीक है, तो काफी आफ्टर लॉन्ग टाइम यू विल बी एबल टू, ये बहुत देर में टाइम आउट आएगा, क्योंकि 6 7 8 का अगर आ गया उसको, तो उसका टाइमर फिर से शुरू हो जाएगा। ओके, और इसको बहुत देर में पता चलेगा। बट usually the notion what you have suggested is the correct notion, and I'm happy that you have picked that, because GBN was a minimal protocol. It's not like it's a perfect protocol. And suppose in this case, suppose we haven't discarded the packet. Let's see, when we get the out of order packet, don't discard it, and rest do everything as such. Then you will see the quick duplicate acknowledgement sending, means previous acknowledgement sending, in this context a very very viable idea. Yes or no?
Yes, sir.
क्योंकि हो सकता है वो सही में खो गया हो, ठीक है, और तुमने प्राइमर बढ़ा दिया, और इधर 6 7 8 को अगर बफर करके रखा है, और उसको थोड़ा और टाइम मिल गया, और 5 अगर पहुंच गया, तो क्या होगा? फिर 5 6 7 8 फिर सब एक्सपेक्टेड हो जाएंगे। ये सुनो, जैसे ही 5 मिल गया, 6 7 8 को अगर बफर करके रखा है, तो हम सीधे क्यूमुलेटिव 9 भेज देंगे।
Yes, sir.
बट यहाँ पे बफर नहीं किया है, टू मेक इट more minimal kind of, ठीक है, but the reason is same why you are sending the duplicate acknowledgement, and later on maybe in TCP you'll be able to understand the ramification of doing this particular thing, that if we do a bit of buffering at the receiver end, this sending duplicate acknowledgement can actually help us. Because here the problem is that we are maintaining. Okay, let's do one more thing, and then I think you'll be more clear. Let's take one more case. Let's take one more case. We take the snip. Now suppose, taking same case, I've sent 5 6 7 8 9 10. My next sequence number is at 9. Fine, means I can next send 9 and 10. Timer is running for 5. It's the oldest packet. And suppose I received ACK 7. Now, if you receive ACK 7, what will happen? See here. Tell me, anybody? Abhigyan?
So base will get incremented.
These will be out of the window.
Yes, sir.
Window will start from here. That's what you're saying?
Yes.
Base will be incremented.
And timer will be started because
Timer
base
will be started because base is not equal to the next sequence number.
next.
So timer will be started as if it is a new packet, because now the oldest base is changing. So using the same philosophy, because you are getting an acknowledgement, may not be a correct acknowledgement, because, and you are getting acknowledgement, a duplicate acknowledgement, because you are, receiver is receiving packets. Receiver is receiving packets, and that's why you are taking this acknowledgement as duplicate and restarting the timer of 5. in hope that suppose 5 may get received and you can shift the base and start the timer of the 6th. So there is a small catch here. Anything else anybody want to say here? Now, as we have seen GBN in action, now let's see the selective repeat. Now this is a bit more tricky, selective repeat protocol. Here receiver will individually acknowledge all correctly received packets. Receiver will buffer the packet as needed for eventual in-order delivery to upper layer. Sender will not send go back N mode. Sender will only resend the packet for which acknowledgements are not received. And there is a timer for each unacknowledged packet. Sender window, N consecutive sequence number. Fine. Again, limits sequence number of send unacknowledged packets. So let's see the window here. Here you have to maintain two windows because here you are buffering the packets. Now, what you are gaining in GBN that you are not maintaining much state in the receiver when you are talking about go back N, because there only one expected sequence number, one variable is maintained. So that was more simple to, you can say, implement. Here, because you are buffering the packets, you have to maintain a window at the receiver end also. So as before, let me take the snip of this and we'll try to make you comprehend. So there is a sender window which is having a send base as before, next sequence number and the window size n. And within a window you can see green one are already acknowledged. They are sent but not acknowledged, and now you can see कि green one पहले acknowledge हो गया लेकिन window नहीं खिसका. Window तभी खिसकेगा जब everything will be acknowledged. Usable not sent and before and white one are not usable. So this is sender view of sequence number. भेजे कई कुछ acknowledge हुए कुछ नहीं acknowledge हुए. And timer is running for not only for the base packet. Timer is running for each and every packet. Now what is the receiver view? Gray ones are expected sequence number but not yet received. Blue ones are acceptable within window. इतने आएंगे तो हम लोग ले लेंगे. They are out of order packet, but we have sent acknowledgement for them. Now receiver window left edge will again shift when you get all the pings here, and then you can shift the receiver window. So at any given time, both receiver and sender will be having different view of pipeline in-flight packets because there is a network in between and variable delay for different packets in between. Now how sender and receiver behaves? Sender, if you get the data from above, if next available sequence number is in window, send the packet. If there is a timeout for any packet, resend the packet, that very packet only, and restart the timer for that packet. If you get the acknowledgement number which is within the window, mark packet N as received. If N is smallest, an acknowledged packet, if जो N आया, suppose इसी केस में पीछे चलें, मेरे पास अगर ये दोनों येलो का आ गया acknowledgement, what will happen? Up to this point, sender window will be shifted because sent and acknowledged. Fine. because as soon as you get all green from the base to some sequence number, window will be shifted. And that's what is explained there. If n is smallest unacknowledged packet, advance window base to the next unacknowledged sequence number. What receiver is doing? If packet n in receive base and receive base plus n minus 1 within the receive window, send the acknowledgement. If it is out of order buffer, don't deliver it to the application layer. Deliver. If it is in order, deliver. और इन ऑर्डर आया और अगर जो ऑलरेडी बफर्ड पैकेट है अगर वो सभी इन ऑर्डर हो गए तो डिलीवर टू द application layer, and window can be advanced to not yet received packet. So what I mean to say that suppose in this here you receive this packet, तो अभी हम application layer को नहीं दे सकते क्योंकि ये मिस हो गया है. When you receive this also, everything will be in order up to this point. So the receive base will be shifted and all these packet will be delivered to the application. Now if you get that packet which is before the window, suppose you get the packet which is here, get any packet which is here, ये कब होगा? Anybody?
So
Sir, can you
duplicate.
repeat?
Duplicate packet. It may so happen that it's a duplicate packet because acknowledgement loss हो गया होगा, यहाँ पे सब कुछ सही हुआ होगा और तुमने दोबारा पैकेट भेज दिया होगा. So when you send a duplicate packet here, again same thing, just acknowledge that packet, otherwise ignore. Fine, otherwise ignore. Whatever else is happening should be ignored. Now see here, selective repeat in action. You send packet 0, packet 0 is received, delivered, expected था, acknowledgement 0 is sent. शाबिर क्लास में है अभी, हाँ अभी मिलाता हूँ. Now as soon as you send acknowledgement 0, fine, you send the acknowledgement 0. Acknowledgement 0 will be received later, fine, obviously. Meanwhile what you have sent, packet number 1, packet number 1 is received, acknowledgement number 1 is sent, 0 1 दोनों सब एक्सपेक्टेड थे. देखो ना रिसीवर विंडो आगे बढ़ रही है, ठीक है. सपोज द साइज ऑफ विंडो इज 4 in our case, fine, receiver window is moving ahead. Now you send packet number 2 which is supposed last, and you don't know it is lost or not, so you'll send the packet number 3 also. Now the window is stalled. Here packet 3 is received, buffered, and ACK3 has been sent. Fine, ACK3 has been sent. Acknowledgement 0 आया, विंडो बढ़ गई, ठीक है. पैकेट 4 भेज दिया. Acknowledgement 1 आया, विंडो फिर बढ़ गई, पैकेट नंबर 5 भेज दिया. पैकेट 4 रिसीव्ड बफर हो गया, 4 का एक्नॉलेजमेंट भेज दिया, लेकिन पैकेट 2 फंसा हुआ है अभी. पैकेट 5 रिसीव्ड बफर्ड, एक्नॉलेजमेंट 5 इज सेंड. यहाँ पैकेट 2 का टाइम आउट हुआ, पैकेट 2 हैज बीन रीसेंट. इधर पैकेट 3 जब रिसीव हुआ, एक्नॉलेजमेंट भेजा गया बट कुछ हो नहीं पाया उससे, क्योंकि 2 पे फंसा हुआ था, विंडो आगे बढ़ नहीं सकती थी। एक्नॉलेजमेंट आया, फिर भी कुछ नहीं विंडो बढ़ी, क्योंकि 2 पे स्टक थी विंडो। When you get the packet 2 received, packet 2, 3, 4, 5, everything is delivered. Receiver window is shifted from 6 to 9 and acknowledgement 2 has been sent. And when acknowledgement 2 is received, now the sender window will also move further. So this is how selective repeat works. Fine. Any questions from anybody? So which is more simple to understand? Which protocol is more simple to understand? Abhigyan.
So selective repeat.
But it is more simple to understand, but more difficult to implement.
Implement.
Now let's see here a very interesting thing. Suppose window size is 3 and you have sequence number 0, 1, 2, and 3. Let me take the snip of this and then it will be more interesting. Suppose window size is 3 and sequence number are 0, 1, 2, and 3. So you have sent packet 0. You get acknowledgement 0, but acknowledge 0 is lost. Acknowledgement 1, it is also lost. This is also lost. Here you have received all these 0, 1, and 2 correctly, and your receive window is shifted accordingly. पैकेट 0 भेजा, 1 2 3 हो गई, पैकेट 1 मिल गया, 2 3 0 हो गई, पैकेट 2 मिल गया, 3 0 1 हो गई। इधर क्या है, एक्नॉलेजमेंट लॉस हो गए सब, तो हम इधर ही फंसे हुए हैं 0 1 2 में सेंडर पे। Now what will happen after some time? 0 will time out. Now you will send a 0 packet. This is not this 0. ये 0 नहीं है. This is this 0. But receiver has no way to identify whether it is a old 0 or a new 0. Here you can see receiver sees no difference in 2 scenarios. Incorrectly passes duplicate data as new in A. A similar situation is this. Suppose you send packet 0, receive acknowledgement 0, packet 1. So when you receive packet 0, receiver window is shifted. Packet 1, receiver window is again shifted. Packet 2, receiver window is again shifted. When you get the acknowledgement 0, sender window is shifted. And as soon as you sender window is shifted, now 3 can be sent and sender has sent 3, but 3 is lost. 3 is lost. Now when you receive acknowledgement number 1, packet will be shifted. 0 done, 1 done. Now you can send 0, packet 0. So this packet 0 is actually a new 0. It is okay here. It is a new 0. So the dilemma is whether it is okay 0 or old 0, which is getting considered as new 0. Here it's a new 0, no problem. Here it is a old 0, but you are considering as nu 0. Now to remove this dilemma, there is a relationship between number of sequence number size and window size. Now if I say in this particular example, our maximum window size, is say 2. Then can this dilemma would be solved? You can check it up later and do some, yeah, yes.
Yes, sir.
So means, and that's true also that if your sequence number size is n, your window size should not be more than n by 2 in selective repeat. You can check it later. And in GBN, your window size should not be, if the sequence number size is n, your window size should not be more than n minus 1 to solve this dilemma. Point. But there is a strong assumption behind this. What is that assumption? Why these window sizes are okay to remove this dilemma? There's a strong assumption behind that. Fine. And that strong assumption can give you this particular window size and your work can be done. But if we do away with this strong assumption, what is that strong assumption we'll be covering in the next lecture, don't worry. Fine. So this is about selective repeat and go back. And now what you can do, you can take some small examples and compare it, run it, and then check it with your finite state machine. And whatever questions you have during this particular exercise, you can ask me anytime in the next lecture. I'm done with my lecture. If there are any questions, you can ask.